This is 8.5 of geometry. So we're going to continue with trig stuff. But we're going to now look at the law of sines. The law of sines works in any kind of triangle. It doesn't have to be a right triangle. So far, when we've been using sine, cosine, and tangent and their inverses, we've been using right triangles. So first look here, we got the sine of A over A. So sine of A, the capital A and capital B and capital C, that's all angles. The lowercase are sides. Okay, so if we look at the picture, the sine of this angle goes over this side, okay, the one opposite it. Same with all, so these go together, and these go together. So it'll get a little clearer when we look at an example, but I want to explain why this works. So you can use any triangle. That doesn't have to be a right triangle, but how that works is that we break it into right triangles. So if you look at this triangle here, we draw the altitude down, so we make these two triangles be right triangles. Okay, so now we're allowed to use our trig functions with those triangles. So if we look at the sine of A, okay, if we were looking at this angle here, sine is opposite over hypotenuse, right? So that gives us H, right, here's your opposite, over B, your hypotenuse. Okay, so they wrote that here. And then if we do the sine of B, that's opposite over hypotenuse, so here's our opposite and our hypotenuse. So that gives us H over A, which you can see there. Then what they do is they multiplied this one by B, and they multiplied this one by A, so that they get H alone, right? You see how these are both H alone? Now they're allowed to set them equal to each other, okay, right here. And how they get to the next step is they take, let's write it out. We've got B sine angle A equals A sine of angle B. So we divide both sides by A. That cancels those off. So over here we've got B sine of angle A over A equals sine of B. And then if we also divide both sides by B, so I stick the B under here, those cancel out. And now we've got sine A over A equals the sine of B over B. Okay, you won't be required to know how we get that, but that's where it's coming from. It's still using right triangles. So, let's look at a problem. Our got it problem wants us to use this triangle and find AB. So we're looking for this side right here, okay? If we look across to the angle, it goes with angle C. So we need to know what angle C is. It's not labeled, but we know two of them already, and we know it has to add up to 180. So we'll call it X. X plus 48 plus 93 equals 180. 48 plus 93 gives us 141. And we'll subtract 141 from both sides. So X is equal to 39 degrees. Okay. Let's just draw an updated triangle for us. So this one, 39 degrees, that's C. A is over here, B is over here. We're looking for this side right here. So I'll stick a Y there. I've got 93 degrees here, 48 degrees here, and 15 here. So what you want to look for is you want to look for an angle and a side that are opposite each other. Remember we were looking at that on the picture? Where there's a number for both of them, okay? So like this one right here has an angle number and it has a side number, right? And then we could match that up with the side that we're looking for and the angle that we have. Okay, so now what I need to do is I need to say, so the sine of 93 over the side, so 15, equals the sine of 39 over y. Okay, you only need to know, you only need two, right? In our, over here, it uses A, B, and C. You don't have to use all three of them, okay? You only need two of these. They're just showing you that all three are, in fact, equal. So once I set it up, Now I can cross multiply. So I get y sine of 93 equals 15 times the sine of 39. Okay, if you want to approximate this first and then divide, you can, or you can divide right away. Sine 93 divided by the sine of 93. So we get that y is equal to, and then I'm going to type that in on my calculator. On the top, I get 9.4. And on the bottom, I get, let's do a couple decimals, 0.999. Then I'll divide those. 9.4 divided by 0.999. That gives me about 9.4. So that other side is 9.4. We're not going to do another one, but I want to just set up another one. So let me clear some space over here just so that you get the idea of what you're putting over what. So if I have this triangle, okay, A, B, C. Let's say this is 36 degrees. Let's say this one is 50 degrees. Okay, and let's say that this side is 8, and we're looking for this side, okay? You got to match up. This angle goes with the side across from it, okay? So these go together, and these go together. The number that you put in your sine, right, sine of something, needs to be the angle. So the 50 is going to go in here. And the side length always goes on the bottom, the 8. Equals, so the sine of 36, the angle goes in top, and x goes on the bottom. Right? And again, like our problem, we could find the third angle if we needed to, if we weren't looking for that side. And then we cross multiply. Okay. Let's try another one. So this one, they're just giving us a description and not actually giving us a picture. So I will draw this picture. Guarantee it won't be to scale, but K, L, and M. So it says LM is 9, KM is 14, angle L is 105. Okay, and we want to figure out this time what the angle is. Okay, so before we were looking at how long the side length is, now we're going to look for the angle. So I'm going to set up opposite sides, right? So this angle goes with that side, and this angle goes with this side. Okay, so I'll do the green one first. We got the sine of 105 over 14 equals the sine of, well, I don't know what that is. I'm going to call it x. The sine of x, remember the angle always goes in the sine, over 9. Okay, and again I'm going to cross multiply. So I get 9 sine of 105 equals 14 sine of x. So I'm trying to figure out what x is, so I need to divide both sides by 14. I'll just leave it like that. 9 sine 105 over 14 equals the sine of x. So I'm going to put this stuff into a decimal, okay? So if I figure out the top, I get 8.7 over 14. I do 8.7 divided by 14, I get 0.621, how about? That is equal to the sine of x. Well, now I need to get rid of that sine out front. Think back, how do I get rid of sine? We got to do kind of the opposite, or what undoes sine? That's the inverse sine. So, sine inverse of 0.621 equals, we got to do sine inverse of the sine of x. And remember, these right here are going to cancel off. So I'm just left with x. And we get x equals about 38.4 degrees, depending where you rounded. Okay, so now we're going to do a story problem. It's really not, they give you pictures, not so based on the words. Says the right fielder fields a softball between first base and second base as shown in the figure. If the right fielder throws the ball to second base, how far does she throw the ball? So we're looking for the distance from the right fielder to second base. So we're looking for this right here, X. Okay, so I'm going to set up my matches. So the 40 goes with the X. And then the 68 is supposed to go with this side, but I don't have any side there. So what I need to do is I need to figure out what this other angle is, because whatever it is the one that goes with this 60. Okay? So we know that triangles add up to triangles add up to 180. So 68 plus 40 plus, let's call it Y, equals 180. I'll stick that on the other side. So 180 is equal to 108 plus Y. When I subtract 108, I get that Y is equal to 72. So I'm going to go in here. This is 72 degrees. So now I got my stuff to set it up. So the sine of 72, what I just figured out there, goes over the 60 feet, equals the sine of 40 over X. Now I cross multiply. I get X sine of 72 equals 60 sine of 40. Your choice if you want to get the decimal now or divide first. I'm just going to divide first. Divide by the sine of 72. X is equal to, well, we'll leave it like this for a second and then find our decimals. Okay, so on our calculators, the sine of 40 times 60 gives us 38.6. And the sine of 72 gives us like 0.95. And when I divide those, I get that X is equal to about 40.6 feet. And there you go. There's your homework.